In the last video of the first session, we're going to go through an entire pipeline in which we are going to try to segment and extract information about nuclei. So let's open the previous image about nuclei. That's not this one. This one, sorry. All right. So the goal is to identify the nuclei in this image. So let's first change the range of intensity. As I told you before, it's always important to have a better idea of what you're looking at. So just try to find something you're comfortable with. And now we're going to apply several operations to extract individual nuclei in this image. The first thing we're going to do is to apply a Gaussian filtering. So to do so, you go to Process, Filters, and Gaussian Blur. And we're going to use a radius of 2. So if you want, you can preview it. So we apply a Gaussian filtering, so we actually blur the image. The idea is that it's going to blur the image in the nuclei, so maybe we lose some information in the nuclei, even though the nuclei are still bright and pretty easy to identify from the background. We're going to also blur the intensity in the background. So now we have a smoother image that's going to be easier to deal with, especially if you have some noise. Problem with noise is that you have outlier pixel in the background, for example, that might have a high intensity. By blurring it, you're just making all this pixel look like dark region, and it's going to make it easier to identify the nuclei. Now the next step is to threshold the intensity. So to do so, you go to Image, Adjust, and then Threshold. And you have this tool that appears. So as you can see, the selected pixels appear in red. So you have 2 sliding bars that you can use. So what you're gonna extract, what is in red here, is what is in this window. So you can, if you lower the threshold, you're gonna have everything. If you have a very high threshold, you have nothing, of course. But you can also play with the second slide if you want to have an intensity that is not too low, not too high, like some band pass, but for intensity. And it looks like this. So in that case, that's definitely not what we want to do, but it's just to show you how this tool works. So you see now, this is the range of intensity that is thresholded. So we just want to extract the pixels for which the intensity is above the threshold. So this one, we're going to put it at the maximum, and then we're going to play with this one to actually find a threshold that allows us to extract everything. Oh, and this came back here, sorry. Okay. So this is very low threshold, but the background, as you see, as we apply the Gaussian filter, the background is really smooth, so we can have something that is pretty low. You can still see, so this is the histogram, so you can have an idea how to use that. We'll see that in the next session. So if I go too low, I'm going to have way too many pixels that are above the threshold. So let's just try to find something. You can also set it manually if you want. So let's say 250, for example, which looks like it's not too bad. Maybe we are missing here, but let's just say we use this threshold. So then you apply it, and that's what you get. So now you have an image that is not a 16-bit, 12-bit actually image anymore, but it's just a binary image with your background. So all the pixels that were below the threshold are now 0. You can look at the value here, 0. And all the pixels that were above the threshold are now 255. Okay? So we identify the pixels that belong to the nuclei. And when the nuclei are isolated, it works fine. We can identify those nuclei, for example. But when nuclei are touching, like those two, instead of having two nuclei, we just have one main component, and we want to individually identify the nuclei. A way to do it is to apply a watershed, a binary watershed. So we'll see that also in the next session. Let's just apply it. So we go to Process, Binary, and then Watershed. So as you can see, we're able to separate those two, those two, those two. It's not perfect, doesn't work all the time. These ones were not separated here. It's certainly not one nucleus. I don't know exactly what it is, but it's not what we want. But it's already better. If we want to do even better, we would have to apply something more sophisticated, or maybe apply a better threshold. But it's not bad. So let's say we are happy with our segmentation. Now we want to extract some information. There's a very simple way to do it. When you have individual objects, you go to Analyze and Analyze Particles. So something you want to make sure is that Add to Manager is ticked, because we're gonna define each individual component as a ROI, a region of interest, and we're gonna use the ROI Manager to deal with. So let's just, now that this is ticked, we just go to OK. And as I told you, now we have the ROI Manager that is open. So it's really nice. You can see that each nucleus has a different ID, and you can either click on one. Maybe if I go there. So you see, so here I clicked in the ROI Manager on the 0001, and you see that the first one is highlighted. If I click, oh no, I need to click on the number, sorry. So if I click here, you see, now this one is highlighted. So now you can extract measurements that are associated with each nucleus. To select which measurements are going to be extracted, you need to define them. So you need to go to Analyze and then Set Measurements. And now you have a list of different measurements that can be extracted. So let's say I want to have the area for each nucleus. The mean gray value, so it's going to be the mean intensity for each nucleus. The centroid, so the coordinates of the center. And let's say that's all I want. You could have other measures like perimeter or standard deviation, minimum and maximum, etc. But let's say I just want these three different features. So I selected them. I now say OK. I select all of them. All the ROIs are selected, and then I click on Measure, and this opens this file. So yeah, maybe we don't need to do that. So here you have the three different features: the area, the mean intensity, and then the coordinates. So if the area and the coordinates look right, the average intensity is always 255. So that definitely is not very informative, but it makes sense, because actually what you have here is an image where, as I told you, it's a binary image. It's either 255 or 0 if you're in the nuclei or in the background. So in the nucleus, the intensity that is observed is always 255. So then the average intensity is 255. What would make more sense is to have the average intensity in the original image. And this is also possible. So let's just close this one. And then we can just open the same image, but before treatment. Okay. And now if I go to the ROI, I just click on show all, and now as you can see you have all the regions of interest that are defined but on the original image. And if I select all regions of interest and then click on measure, now you see that the average intensity is not 255, but it changes depending on the nuclei. And I'm just curious, this one is very bright, so it should be much higher. It's 35. So let's go to the 35. And as you can see, this is the ID 35, and the average intensity is over 1000, which is at least, you know, double to the other one. This one is pretty bright too, but it's definitely brighter than the other ones. And of course, then you can save your file, and so let's save it as results, for example. And now you can open it with Excel, and if you want to analyze your image, do some statistics and so on, you have access to everything. If we go back to 35, that's the one with the high intensity. Okay, that's nice, but if you have 100 of images that you need to analyze, you don't want to click for each step, especially because first it's going to take time and maybe you're going to make a mistake. Now, if you want to do that, there's a very powerful tool in Fiji, which is called a macro recorder. You can do macros, so we'll talk about this in the quantification session, how to do macros, but I'm just going to show you how you can use the macro recorder to at least save all the different steps you use, so you can apply the exact same analysis to another image and even use this different step to analyze other images. So let's open the same image again. Okay, and now let's go to plugin, macros, record. So you have this window that opens, and we're gonna just apply the different step we use. So we started with a Gaussian filtering, so I'm gonna do it again. Process filters, Gaussian blur 2. All right. And now if you go to the recorder, you can see that it recorded one comment, and that's pretty straightforward. Let's run Gaussian blur sigma equals 2. All right, so let's do now the thresholding image, adjust threshold, and we said that 250 was okay, so let's do it again, 250. Okay. All right, apply, okay. Next step is the watershed, the binary watershed, so process binary watershed, all right. And the last step is analyze, and analyze particles. Okay. So if we just look at each line, it's pretty straightforward. Run Gaussian blur, set those threshold, default dark actually is not used. It's set threshold to 50, and then black background, so it's just applying the threshold, convert to mask, run watershed, run analyze particle. Okay, so the nice thing is that you can directly create a macro with all the steps. So let me reduce it. Okay, now let's just close this image and open it again. All right, And now if I go to the macro that is actually exactly what we recorded and run it, you see you get in just one click all the different steps you did before, and you can go there. So let me redo that. You can just go there and measure, and you get your files. Now interestingly also is that you can open another image, so this one, which is also a nuclei image that looks very similar to the other one, and run the same macro and do the same thing. And if you want to do it for another image, you can do also another image, run it. Okay, you get it. So we'll see in the quantification session how we can do it even in a more efficient way, but it's just to give you an idea about what you can do, and you can see how macros can be powerful to both process a lot of images always in the same way, and even keep track of what you did for a given analysis.